Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And of course, we'd love to talk to you about hosting your telescope under our clear, dark skies. And today we're going to process this image of the Whirlpool Nebula. A few days ago, I was contacted by a customer who wanted to do some imaging by the hour. He wanted 2 hours of data of M51, the Whirlpool galaxy. And typically, you would never see me processing their data because in an hourly rental situation, that data really belongs to them. But in this case, Jim gave me permission to use his data to record this video. So we're going to walk through how I processed this image of M51, which was a combination of plain luminosity with a color camera and a dual narrowband Optilung L-enhanced filter. We'll process that in PixInsight and Photoshop. So as I said, we're going to process this image in a combination of PixInsight and Photoshop. A little of the background information. The data was captured with a plane wave, CDK 12.5. That's the smallest plane wave. But I really like that focal length of 2541 millimeters. It was captured using an ASI 6200 MC Pro, which is a one-shot color camera. And I don't think I've done too many processing videos using a color camera, so this will be a little bit different. So the first thing I do is go into PixInsight, and after I've captured the data, I always review it and pull out any bad subs. And the first thing I do is go into Process, Image Inspection, Blink. And what I want to do here is just step through the data and remove any bad frames from the folder that they're in. So we just open the file list. So we'll navigate to where the images are stored. And this is going to be on Nook 1. There's the Whirlpool, and his data was captured on January 5th. And I've actually already reviewed this, so I just select all and hit open. So there won't be any bad frames in here, but just to show you the process, once they're all loaded into Blink, what Blink lets you do is very quickly go through from image to image and look at them. One of its peculiarities is when you first load the data, it will calculate a screen stretch for the first image and then apply that stretch to every subsequent image. Since this is a combination of dual narrowband and luminance, I really want to calculate a stretch uniquely for each one. Otherwise, if we look at the luminance, you can see they're overexposed, or they appear overexposed. So we just click this top histogram icon that says Apply an Automatic Histogram Transformation to all images, and what it means really is to every image individually. And that way, as we step through and look at the different images, they all have an appropriate screen stretch, and you can get a better feeling for what each one really looks like. So there's the L-enhance, which I'll talk more in a little bit about the nature of a dual narrowband filter. And then there's the luminosity data. And I always overshoot. In other words, he asked for 2 hours of data. I think I actually shot more like 3 or 3.5. And then when I took out the lesser quality frames, we were left with just a little under 3 hours. So that's what I sent him. So he actually contracted for 2 and received almost 3. If I do find something that I want to remove, remember these are all in one folder. And what I want to do is have one clean folder. So I want to move any image that's not up to par out of that folder. And the easy way to do that in Blink is to go to the Move Selected File to a New Location icon. It's the fourth from the right. And when you click on that, you can select a folder to move it to. I just keep a folder on my D drive called rejects. And so if I select that folder, then it would move this file from the data file that it's or data folder that it's in to the rejects folder. And I don't actually want to do that because this is a good frame. But now we have a folder with just good data in it. So we'll close this. Now the other thing I'm going to do with this video that's a little different. Normally I use my shortcuts that are my workflow over on the right. For this video I'm going to do it kind of the hard way without using the shortcuts. You'll see in the process how to create a shortcut to use later, but we'll do them the hard way and pick everything from the menu. So the first thing we need to do is run WBPP, which is the weighted batch preprocessor, and that's a script located under Script, Batch Processing, Weighted Batch Preprocessing. And this is a great addition to PixInsight because it really automates the calibration and integration process. And the end result of this is master files that you can then continue processing artistically. So what we're doing in WBPP is just kind of the, turn the crank and move the data through. There's not much creativity going on. So this is just how it was configured the last time I ran it. So I will click the reset button at the bottom, and I want to keep the settings from the last session and also clear all files, and I pretty much always will click these two buttons. So now we want to go select our light frames. So the tabs at the top show you different tabs for the calibration frames and the light frames and then calibration details. I want to go to the bottom where it says plus lights, and we'll navigate to that folder that has the light frames, which was the last one we accessed, so we're already there. So this is the Whirlpool January 5th. So like we did before, I'll click on the first one, Control A to select all. That would be Command A on a Mac, and click Open. And there's the files that we opened, and if we look at the post-calibration tab, it'll tell us we have 2 hours and 40 minutes. Now we need to load all the calibration frames, and along with sending him a Dropbox transfer of all the light frames, I also sent him a Dropbox transfer of the calibration frames. And you can load these individually by going to Flats, Darks, and Lights and doing the pluses down here. I like to load everything as quickly as I can with one mouse click. And if you look at the pluses down here, the first one says plus directory. So if I choose plus directory and then navigate to that folder where I saved the calibration files, and I happen to have it called color combined, and then when I click select folder, what PixInsight's going to do is go through that folder and all of its subfolders and find any frames that it knows what to do with, and it can tell from the metadata whether it's a dark or a flat or a bias, and it'll load it in the appropriate spot. So now we have our flats loaded, our darks, and our biases. And if we look at the darks, for instance, we'll see that there's 600 second, 300 second, and 120 second. Well, if we look at our lights, we only have 600 second and 300 seconds, so we don't need the 120 second darks. So just to speed processing, I'll select that group and then remove selected. On the lights tab, I want to check the registration parameters, and I'm using by cubic B spline as the registration method, and that seems to work real well for my data. For this data, we're also going to apply cosmetic correction, and we'll do that and some other settings on the calibration tab. So the calibration tab is where you do most of your setup, and we need to do a couple things here with both the flats and the lights. First, select one of the flat frames, and over on the right hand side we can see CFA settings. Now CFA just stands for color filter array. That's a shorthand way of saying this is a color image. It was taken with a camera with a color filter array, which gives you red, green, and blue data. And we need to tell PixInsight by checking the CFA images checkbox that this is color data, and both the L-enhance and the luminance data are CFA. So I want to click the Apply to All Flat Frames, and it'll ask if I really do. I'll say yes. Now we'll go to the light frames, and we need to do three things here, and working from top to bottom. We'll start with the pedestal value, and I want a pedestal of 300, and apply this again to all light frames, in other words, to both the L enhance and the luminance. On the cosmetic correction, we have a cosmetic correction template that I've already created, so I'm going to select that, and again apply to all light frames. But let's talk a little bit about how I created this cosmetic correction template. And to do that, I'm just going to exit out of the WBPP, because I don't think I can run. I have to exit out of this in order to create this cosmetic correction. To do that, we'll go to Process, All Processes, and find Cosmetic Correction in the list. There it is. And there's just really a couple checkboxes we need to do. We need to open up this Auto Detect and click Hot Sigma and Cold Sigma, and I believe I reduced these to around 2 sigma, which makes it a little bit more aggressive on removing hot and cold pixels. Now that we have this configured, we need to save an instance of it so that WBPP knows where to find it. And to do that, we just use the triangle icon at the bottom of the panel. And it's these buttons at the bottom that generally do things with processes. So the triangle will create a new instance, and when I click and drag this out, you can see it created an icon. And this icon represents the cosmetic correction process with these settings. So in fact, I can close this now, and I would want to give this a name. And I do that by right-clicking on it and choosing Set Icon Identifier. You can't have spaces, so I'll call it Cos Correct 2. And then you can just park it somewhere on the screen. And in fact, if I save my project now by going to File, Save Project, it will save whatever icons I have open. So that's how I've created a project that I save with all of these saved process icons with the settings already intact. So let's go back to our WBPP. And it takes just a few seconds to open. And it's one of the nice things it does is it remembers where you are at. So all the settings we had before are still intact. And if we go to our light frames, and you see now if I open this cosmetic correction template to choose, it says, oh, there's actually 2 of them there. So I could use my Cos Correct, or I could use the Cos Correct 2 that we just created. And we want to apply this to all light frames. Next, we go to the CFA settings, and again, we need to click that these are CFA images because these were captured with a color camera. If this was a mono camera, you would not choose this. And we need to tell it the mosaic pattern, and in our case, and in fact most of the cameras are going to be RGGB. And again, apply this to all light frames and confirm yes, I really do. The last thing we need to do is select where we want to save all of the files it's going to process. And it will use a fair amount of working storage, so it's not a bad idea to just have a working folder somewhere to save all of the process files. The registration reference image selection we'll leave on auto. We could manually tell it which frame to use for a reference. And then we just need to select the output directory. And to do that, I'll go to the folder, which is just called PI swap files. And this is the Whirlpool for the video. And select folder. And so it's going to store all of the working files now into that folder. At this point, it's ready to run. And I would just click on Run. And it will do a quick review to see if there's any errors. If there are, they would show up. It's also confirming that I have sufficient space. It's going to use 50 gigabytes out of the 283 available on this drive. and then I would just click continue to start running. So once it starts running, it will give you a panel that shows the status, and once it's completed, when you close that, it will bring you back to the WBPP window that you just used. And at that point, we're done with the WBPP, and we can exit from WBPP, and now we're ready for the more creative part of the processing. We're going to have two master files to work with, one with just luminance, which is just simple RGB color, and the other is captured with the dual narrowband. And let me digress a little bit and explain what a dual narrowband is versus a color image. So a color camera is just a monochrome sensor with a color filter array that has red, green, and blue filters over individual pixels on that color filter on that sensor. So some pixels will pick up red, some will pick up green, some will pick up blue. But if you look at the actual color response, or the color band pass, it's not just a single value for red, single value for green, and a single value for blue. In fact, it's a bit of a range. So we can see the blue, for instance, the scale here is in wavelength in nanometers. The blue is picking up all the way from 400, kind of peaks in the 450 range, but then it tapers off up to 500 and even a little bit below. Green is kind of a bell-shaped curve in the middle, so it picks up the green colors, but it also picks up some of the blue and some of the red, and the red also overlaps quite a bit with the green. And these shapes are fairly typical for color cameras. Generally speaking, if you buy a Sony camera or a Nikon camera or an Olympus camera that has a Sony sensor in it, the underlying sensor is probably the same between the different cameras with the same image size or sensor size and pixel size, but the color filter array is probably fine-tuned and unique to that manufacturer. So different camera manufacturers will have the same sensor, but with slightly different filters and slightly different filter curves. This happens to be the one for the ASI 6200. So it's picking up a broad range of colors with each filter, and that's why these are called broadband filters or broadband imaging. One of the fun things with astro images is that you're frequently photographing nebulae. And nebulae fall into two categories, reflection and emission. A reflection nebula is just reflecting starlight, so it's just a cloud of dust reflecting light. An emission nebula is kind of like a neon light in the sky. It's one of these gases, hydrogen, oxygen, sulfur, nitrogen, one of those. And when it's energized by the X-rays and gamma rays and radiation from stars, it gives off light the same way a neon lamp glows. But each element gives off a very distinct set of colors, and we can use that to photograph very specifically just those elements. So if we look at the oxygen, it actually is sitting here in this blue-green range of colors, and hydrogen is sitting in a very red range of colors. Sulfur is actually even a little bit more red than hydrogen. And what a narrowband filter does is it picks out just this wavelength of oxygen or hydrogen or sulfur, and you'll frequently see those filters described with a band pass, and usually 2.5 to 3 nanometers is going to be the most precise. What that means is it picks up precisely that wavelength with an error of just 2 or 3 nanometers, or a span of just 2 or 3 nanometers, so very precise. One of the values of narrowband imaging is it's pretty much unaffected by light pollution and much less affected by moonlight than broadband imaging. But if you've got a color camera, typically you use these narrowband filters with monochrome cameras. If you have a color camera, you can use what's called a dual band pass or a dual narrowband filter. this is the Optilong L-Enhance, and that's the one I was using. And that filter is designed so that it has two band passes. It passes the light right around the O3 band and also just around the HA band. So if we overlay the broadband response of that sensor, we can see that the O3 is going to be more or less equally divided between the green and blue channels, and that the HA is going to be almost exclusively in the red channel. And so that lets us actually capture hydrogen with the red channel and oxygen with the green and blue channels, so we get some of the benefits of narrowband imaging with a color camera. So let's jump back over to PixInsight and let's start processing. So to open the images that we just created with WBPP, I'm just going to double click here on the background, and that will bring up the Open File dialog. And we're going to navigate to the folder where we saved the images. And you can see there's now a bunch of new folders. There's calibrated, cosmetized, debayered, logs, master, registered. PixInsight created these and populated them with the intermediate files as it was processing. The final result is in the folder called master. And if we look in the folder called master, we can see that we have two master flats that it created, one for the luminance and one for the L-Enhance filter. And then we also have two master lights, and these are the ones that we want. There's a master L-Enhance and a master luminance. So I'll click on one, control click on the other, and click open. And that will open these two files so we can start working with them. Now they're going to look almost completely black initially because everything in the sky is really pretty dark, and it takes long exposures to collect a lot of data, but almost all of the information is down in the very darkest end of the histogram. PixInsight has a tool for viewing these files, and it's designed just for viewing, and that's called the screen transfer function. It's an auto stretch, and it's the same auto stretch that we used in the blink process. So I have my toolbar at the top somewhat simplified, so I have only the visualization icons here. The two that I use, the 1 second from the right is the STF auto stretch, so it applies an auto stretch to the currently selected image, and the one on the far left will enable or turn off, and usually I'm using it to turn off the screen stretch. So let's go ahead and do a screen stretch on the so this is the L-Enhance. You can see it in the file name right here, and it's quite typical that the color is going to be off somewhat. Let's look at the luminance, and we'll do the same thing. We'll click on the STF, or the screen transfer button, and there's our luminance data auto stretched. So generally the first thing I will do, there's a little bit of a gradient here. The first thing I will do is run dynamic background extraction. And to do that, we'll go to Process, All Processes, and find Dynamic Background Extraction. And we need to do a couple of things to set this up. First, we need to create a set of samples. And what I like to do is create a fairly large sample, and we can go to where it says Sample Generation, and we want this to be quite a bit bigger. So by clicking on an image, now it knows what we're talking about. And let's just click once and see how big that sample size is. That's pretty small. So I'll just tap the delete key to delete that little green square. And let's make this something like 300. Now I'm making this large because this is a 62 megapixel camera, so there's a lot of pixels here. Even that's pretty small. That's better. So I'm just going to go around the perimeter and click here and there, and I want to avoid clicking on stars, and if there's a some sort of nebula or detail that is happening around the edge, I would want to skip that. So I'm just creating sample points here that we're going to use, or it's going to use, to remove this gradient. So now that I've created this, the samples, we can look at the image correction, and we want to use subtraction. And for our parameters, we want to set a tolerance, and I have to look at my reference because I normally have this saved. I want a tolerance of 2. A shadow relaxation of 6, and a smoothing factor of 0.25. So with these settings, now I don't want to have to do this every time I load an image and open up dynamic background extraction. So remember, we used the triangle down here to drag out a new instance of the cosmetic correction. If I drag out a new instance of my dynamic background extraction, like before, it's saved with all of these configurations in it. So now I can apply this to my first image, and then I can go to my second image and apply it there. Now, the way dynamic background extraction works, it has to do some initialization when you first open the image. So I can apply this one just by clicking the checkbox, and it will apply it to the current image. But in order to apply it to the other image, I should have changed this to discard the background model and replace the target image, so that we don't create a bunch of new. So there I just drug out a new process. So I'm actually going to close these and do it again. So we'll apply this, and now it will change this image without creating new ones that get in the way. So that's what it looks like with dynamic background extraction applied. If we click the screen transfer function to update that. So now that has been applied. In order to apply it to the L-Enhance, we actually have to close it and reopen it. Remember, I said it does some initializing, but we did save a copy of it down here. So I will close this. Yes, I really want to close it. Now I'll just click on the L-Enhance version, double click on our saved process icon. There's all of our sample points, there's all of our settings intact. Now I can just click the checkbox. Now, these settings are actually pretty universal. You can use these on just about any image. So this is one of those things that I would rename this process icon like we did before by right-clicking and setting the icon identifier, and then save it as a blank project. So from now on, I don't have to go through all of this setup. But at this point, we are done with that. And I'm going to delete. I'm going to go ahead and delete this since I actually already have a saved version over here. So the next thing we want to do is run Blur Exterminator to clean up some of the fuzziness. Now, Blur Exterminator is an AI tool put out by Russ Kroman, RC Astro, and don't let the AI moniker fool you or scare you. It's using a very basic, fundamental, historically relevant process called deconvolution. All images get blurred, which a fancy term for blurring is convolution, and what deconvolution does is through some means it's given a set of factors to put into a formula that is the inverse of the blurring function. So if you know how something was blurred, let's say it was blurred by multiplying by 2, you deconvolve it by dividing by 2 and taking away, and that's way oversimplified. What the AI portion of it is doing is looking at the shapes of stars, and from that applying some neural network to help it intelligently guess what was the blurring function, what parameters need to go into the deconvolution formula in order to deconvolve or remove the fuzziness in that image. So the artificial intelligence is being used to determine factors that go into the historical, traditional deconvolution formula. So it's not creating data, it's not pulling in Hubble data or any of those things that you sometimes hear. Now, I'd like to save time, because remember I said I like to be efficient. So I'm going to bundle these two images into something called an image container. And to do that, I'll just right-click on the background and choose Image Container. And it gives me this window. This window is where you build an image container. And what I want to do is add these two views. So I click on the Add Views icon, and there are the two views that are open, and I want both of those, so I'll just select all. I could also just double-click on one or the other to select just it, and then click OK. Now, this is not an image container, but we can use this to create an image container by, again, using the triangle, drag out a new instance. We now have an image container. So I can close the dialog box. And what I want to do is apply Blur Exterminator in a correct only function to just correct the stars. So let's go to Process, All Processes, and we want to find Blur Exterminator. There it is. And we're going to leave pretty much everything as it is, except we're going to click Correct Only. So it's only going to address the stars. Now normally I would either click on the square to apply it to one image, or I can use the triangle and drag it to an image to apply it to that image. I'm going to actually drag the triangle up to this image container, and it will apply Blur Exterminator to both images one after the other. So I'm going to pause while it's doing that, and we'll be back in just a minute. Now that Blur Exterminator is done, the next thing we want to do is to do spectrophotometric color calibration. And I'm actually going to run it on both of these images, even though it's really not proper to use it on the dual narrowband image. So to get to that, again, I have a saved process icon that I'm not going to use. So we'll go to Process, All Processes, and Spectrophotometric Color Calibration. And there's a few things that you have to do to set this up. So to start with, I believe it defaults to the average spiral galaxy. The sensor we're using is a Sony, so this is the Sony IMX 411, 455, and so forth. And the red is going to be the Sony color sensor R, same for G and B, so this is a one-shot color camera. And you can choose generate graphs if you want to see those, or uncheck that if you don't. The other thing that's important is, and I'm not going to go too deep into this, but there's actually two Gaia data sets that you need to download and install for PixInsight. It's a pretty simple process. It does take a little bit of time to download depending on your internet speed, and there's lots of information on either the PixInsight website, or I'm sure you can find tutorials that show you the details. Basically, there's two Gaia catalogs, one for plate solving and one for spectrophotometric color calibration. And you have to download both of them. They're not interchangeable. And then once you download them, of course, you extract them from the zip file and save them somewhere, and then tell PixInsight where that's stored. And that's what's chosen here under the catalog, is the Gaia DR3SP, and I also have checked background neutralization, and that's going to happen automatically. So once it's configured, if you recall, I want to run this on both images, and we have this image container. So again, I'll grab the triangle and drag it onto the image container. And now PixInsight will run spectrophotometric color calibration on each image consecutively. So again, we'll pause, and I'll be back in just a minute. Okay, spectrophotometric color calibration is done, so I can close this window. Or if I wanted to save this process setup, again, I would just create the process icon by dragging out the triangle and then saving it over here on the right for use later. So now I want to run Blur Exterminator on each one of these images again, and we can just take a quick peek at them by updating the screen stretch. There again is the dual narrowband version, and this is the luminance or full RGB version. So now I'm going to run Blur Exterminator in the complete process. So I'll unclick the correct only. So this time it's going to run it on the entire image. So that means it's also going to be sharpening the nebula in the background. So again, just like we did before, we grab the triangle and drag it, instead of dragging it onto the files one at a time or the images one at a time, I'm going to drag it onto this image container, and that's going to cause PixInsight to run Blur Exterminator now on each image one after the other. Okay, we are done with Blur Exterminator, so we'll close this window. And now it's time to stretch the images. And there's lots of ways to stretch the image. The images are still in their linear state, and they only look like this because we are applying the automatic screen stretch. Again, if I turn off the screen stretch, you can see the image is still just almost black. And when I turn on the screen stretch, we can see what data is there. In this green bar over on the left side of the image, on the image name tab on the left, that green line shows us that it's applying an auto stretch. So for me, I don't worry a lot about getting a detailed stretch in PixInsight because I fine-tune everything in Photoshop. So for me, I can use the screen transfer function. And the way I do it, that you have to do two things. First, go to the screen transfer function right here in the all processes, and you can click on the nuclear button to apply a screen stretch. On most of the panels there's a little star with a cross over on the bottom right. That will reset that function, and then the radioactive button applies the auto stretch. And you can start to see there's some little indicators over here showing where the settings are. In order to zoom in and see what's happening there, I'm going to click on the plus sign, and then you'll see now when I move my cursor over the bar, I have a plus sign, and I can start to zoom in by just clicking, and I want to click between what is the black slider and the midtone slider to spread those out a little bit. And notice the link is highlighted. That means we're stretching all three channels the same. And since we've already done color calibration, we want to stretch red, green, and blue uniformly. Now if I want to fine-tune it a little bit, which I usually do, I can come back and select the edit tool. And now I can click and drag those little indicators back and forth to either brighten it or darken it. And what I'm watching here is the center of the nebula. It's very bright, and I don't want that to blow out. So I'm going to darken the white slider down to the point that I can start to see some detail here in the brightest area. And then I'm going to back off on the blacks so that I can see this nebulosity around it. And this might be a good opportunity to actually stretch this one twice. I've got other videos, I think, where I do that, but for the purposes here, we're just going to do the simple stretch like this. Now, unfortunately, I can't just apply this like I do most other processes. There's a little bit of a trick. What I have to do is go to the histogram transformation tool, which is, again, under all processes, and histogram transformation tool. And the trick we're going to use is to drag the new instance, this triangle, from the screen transfer function down to the bottom bar of the histogram transformation function. And when we do that, you see the line here, that curve? What it did, it copied these settings from here down to the histogram. Now I can apply the histogram transformation to this image by either dragging the triangle onto the image, or in this case I'll just click the square, and that will apply it. And the image immediately turns white. And the reason is we've now stretched the image. It's now non-linear, but we're also still applying this screen stretch, so it's being stretched twice. So now we need to turn off the auto stretch or screen stretch. The green bar goes away, and now that's what that image actually looks like. Now we'll do the same thing with the Enhance data. Again, we'll do the stretch. And I don't see the slider, so we may have to click on the minus. And I'm just clicking to bring them into view. Go back to the plus sign, click in between them to spread them out a little bit. Now I can take the edit and adjust the brightness overall here. Now on the Enhance, eventually it's just these red spots that are the nebula within this distant galaxy that we're going to be pulling out and adding to the RGB data. So I mostly want to make sure that those look good. And when I'm happy with that, I will again drag the triangle down to the histogram transformation, apply that, turn off the screen stretch, and we now have both images stretched. The last two steps are to apply Noise Exterminator and then Star Exterminator. So to apply Noise Exterminator, we'll go to Process, All Processes, Noise Exterminator, and the defaults work just fine with this. And again, I'm going to use my image container because it still is referencing these same two images. Drag the triangle to the image container, and now it's going to run Noise Exterminator on both of those images. Noise Exterminator is done, so we can close this window. And the last thing we want to do is remove the stars so we can process the galaxy separately from the stars. And to do that, we're going to use Star Exterminator. Now, if you don't have Star Exterminator, there's also StarNet++, which comes with PixInsight. It doesn't work as well as Star Exterminator, but it is free. Star Exterminator, Noise Exterminator, and Blur Exterminator are all purchased add-ons from RC Astro. So to apply Star Exterminator, there are two settings that we want to make sure we have. We want to make sure that we're generating a star image, and I want to use the unscreen stars option. So again, we'll just drag the instance onto the image container, and Star Exterminator is now going to process this image, and it will remove the stars from this image, and then it'll create a new corresponding image that has just the stars. So Star Exterminator is done, and the last thing to do is to save these files as 16-bit TIFFs that we can then work with in Photoshop, and all additional processing will be done in Photoshop. So we have 4 files here. We have the Enhance stars, which we're not going to use. We're going to use the RGB stars, so we don't actually need this file. So we'll just move it out of the way. Here are the stars from the Luminance RGB. So we'll go to File, Save As, and navigate to the folder where you want to save this file, and the finished processed files I usually just save in the same folder as the raw data. So we want to save this as a TIFF file, and when I select save, we'll check 16-bit for TIFF options. If this window doesn't come up, then that means you didn't select TIFF. Click OK. Minimize that. Here's the RGB with the stars removed. So again, file, save as. We'll navigate to the folder where we want to save it. And we'll have to choose TIFF, save, and 16-bit TIFF. And then lastly, this is the Enhance data. File, save as. So navigate to the correct folder. Save this as a TIFF file. And again, we'll choose to save this as a 16-bit TIFF. So at this point, we are ready to go to Photoshop. Okay, let's start in Photoshop. And if you've seen any of my videos before, you know what I'm going to do first. We're going to go to File, Scripts, Load Files into Stack. And what this lets us do is load individual files as layers in Photoshop. And it brings up this Load Layers dialog box where we'll browse for the files that we want to bring in. And we just saved those from PixInsight. And just to make sure we get the right ones, I'm going to change this so that we have the files in descending date sequence to make sure I get the latest ones. So here's our Enhance, our Luminance, and our stars. And those were all just created. So click OK, and then OK again. And this will load each one of those files as a layer, and the layer name will be the name of the file. So here's our Enhance, and we'll just do some housekeeping. We'll drop it into a group. And the easiest way to put a layer in a group is to select the layer or layers and Control-G, Command-G on a Mac to create a group. Double click on the group name, and we'll just name this LE for Enhance, and then I'll turn that off. This is our RGB, so again, Control-G, RGB data, and I'll collapse the group, turn that off for now. Here's our stars, Control-G, change the name to stars. And if you remember, we chose the option to unscreen the stars. So the inverse of that, we'll put this layer group, and notice this is the group, not the individual layer, but the group in screen blending mode. And then we want to drag this whole group up to the top of the layer stack. Excuse me. Didn't think I was going to sneeze. So if I simply turn the RGB layer on, we're basically back to where we left off. To me, this is upside down, so I'm going to rotate image rotation 180 degrees. Now that looks right. Now, because we've separated the stars from the background, we can work on each individually. So let's go down to this RGB layer. I'll open it up and select the layer. And let's add a levels adjustment layer. And we'll darken the background a little bit and then brighten the mid-tones. And we might be careful that we don't over brighten the center here. But we can play with this with levels, and if we want to get even more sophisticated, we could adjust this with curves. And just, finding a nice balance. Now we've got a bright area down here, and in general a little bit of unevenness in the background. So trick I like to use is to go just below the stars layer, and we're going to add a solid color layer, and I'm going to set it to red, green, and blue values of 19, 19, 19, or hex values, which is what this little number sign, and by default what's selected when you open this. The hex version of that is 13, 13, 13. Click OK, and then put this in lighten blending mode. So what this does, any place that is darker than this solid color of 19, 19, 19 is going to be rendered at that level. So you can see as I darken the background, darken the blacks in the RGB layer, it only gets so black. And if you look at the edge, you can see it never gets as dark as the background. And so we want to find kind of a happy medium where we're just touching this 19, 19, 19 and letting it fill in the dark areas. Now there's a couple things, places I want to adjust locally, and I'm going to do some local burning and dodging. The way I'm going to do that is I'll add a blank layer, and again this is still within the RGB layer group, and I'm going to change this group to soft light blending mode. And what soft light does is any place I paint on this with black, it will darken what's below. Any place I paint with white, it will brighten what's below. And I'll do that with the brush tool in a low opacity of like 5 to 10%. So right now black, as you can see in the toolbar, is our foreground color. And there's a little bit of a streak here of some glare from a nearby star. So if I just paint in this area with black, and I'm going to increase the opacity to 10% and go over that several times. What that's doing, it darkened it, but it didn't turn everything black. In other words, the stars and other details that were there are still there. And there's a little bit of unevenness in this corner, a little bit up here. Now I can also come into the center and darken it a little bit, and then switch to the white and just brighten this halo a little bit. We might want to add some saturation to this, so I'll add a hue saturation adjustment level layer, and as we increase the saturation, that starts to bring out a little bit more of the color in that galaxy. So it's looking pretty good. I'd like to see a little more color in the stars, so I'm going to go to the stars group, click on the stars layer, and then add a hue saturation adjustment layer above that, and I can increase the saturation of the stars. And again, now this is affecting just the stars and not the underlying galaxy. The last thing I want to look at here is the L-enhance data. And let's turn that layer group on. And it looks quite different, and it also has a lot of noise in the background. But we've already got the background, we've already got the detail of the galaxy. As I said, all we really want is the red hydrogen alpha detail. So we're going to do a couple things. Within the L-enhance group, and I'm going to turn off the stars for now. Within the L-enhance group, I'm going to add a levels adjustment so that we can darken the background and brighten the highlights. And then I'm going to change at the group level. I'm going to double click to the right of the layer group name, and that's going to bring up our advanced blending options. And notice here in the center we have the red, green, and blue channels. And if you recall, the hydrogen alpha data is really living just in the red channel. So I'll just uncheck green and blue, and now we have just red coming from this layer. And the other thing I'm going to do is put this in either lighten or screen blending mode. And lighten looks like it works pretty well right off the bat. Let's zoom in a little bit, If I turn this layer off and on, you can see how it's just bringing out the detail from that nebula in the arms of the galaxy. Now, it's also bringing out quite a bit here in the core, and we probably don't want that effect, or at least we want to diminish it. So I'm going to do that by adding a layer mask to this group. I'll do that by clicking on the icon that looks like a front-loading washer, and that adds a mask that still has everything revealed. Again, I'll grab my brush tool with black as my foreground color, and this time I'll go to a much higher opacity and make the brush smaller with the right bracket key. You can use actually that's the left bracket key. You can use left and right bracket keys to make it bigger or smaller. And I'll just paint with black here in the core to hide that effect. If we want a little bit of it to show through, we can click on the mask and we can change the density of the mask in the mask properties panel. And that would let a little bit of that show through. Let's do about like that. Turn the stars back on. And we're pretty close to a finished image here. If we want to now come back to the levels adjustment, we could play with this a little bit and see if we want to bring out a little bit more of that HA. And this is just a matter of adjusting this to taste. So that's a pretty well finished image. We're getting some red noise here. That's probably from the L-Enhance. Let's turn it off and see. Yep. So what we're going to do, we're going to go to this L-Enhance layer, and I'm going to paint with a black brush. So I'll tap X to make that black my foreground color. 100% opacity, 100% flow. I'll make the brush bigger, and we'll just paint black on the mask to completely hide this layer. Every place except where we want the effect, and that's in the center of the galaxy. So we'll just paint with black everywhere, and actually now I have to take the opacity up to 100% to have that effect. So that probably looks pretty good at this point. So at this point I'm going to call this image done. Just to review, we did our integration in PixInsight with WBPP. We processed the files into RGB and L-Enhance master files that we stretched and saved as 16-bit TIFFs without the stars, because we had separated the stars using Star Exterminator. We opened these as layers in Photoshop and did our final adjustments in Photoshop. At this point I would save this, go to File, Save As, and I want to save it with all the layers intact because I may want to come back later and fine-tune it. And I will typically save this on my C drive in my Photos folder, and I have a folder for 2024 photos, and I'm going to choose the large document format, .psb. And the reason you save it as a .psb is the file becomes too big for a .psd native format, or even for a TIFF format. So now that that's done, I could import this into Lightroom to make any final adjustments there, and also any final cropping. So let's go to Lightroom, and I want to go to my 2024 folder. And we just right-click on that folder, choose Synchronize Photos. It found one new photo. This is one that I previously processed. So here's the one that we were just working on. So I would typically then open this in the develop module, and some of the things I would typically do, excuse me, I might darken the blacks a little bit, and again I want to make the background black so I can make sure I don't drive this all the way to pure black. I want to leave it just a little bit brighter than the black background. You can see from the histogram we don't have anything close to pure white, so I would probably increase the brights a little bit, maybe something like that. We might bump up saturation even a little bit more. We might play with the presence data to add a little clarity and maybe a little texture. One thing I find is that a little bit of negative dehaze, if you watch these areas of faint nebulosity, a negative dehaze frequently brings those areas out nicely. And this is also where I would finally crop the image. So I would decide if I want this to be, the original 2:3 format, 8:10, whatever aspect ratio, and crop the image, maybe give it a little bit of a jaunty angle. And then at this point I would use the export function to export this image as a JPEG, and I have a whole variety of saved presets. The Udro JPEG is the one I frequently use for posting on Facebook, and it's just saving it into my website JPEGs folder, and it's saving it at 1920 pixels wide on the long edge. It's applying sharpening based on screen usage, and it's also adding the Utah Desert Remote Observatory's watermark. So I choose export, and we can see on the status bar that it's exporting that file. So this is why I wait until the last minute to crop or to resize images, because I never know how I'm going to use it. But at this point it has saved it, and we can go to that JPEG folder. Just navigate to it quickly. There's the file that we just exported, and if I just double click on that to view it in the image viewer, there it is, ready to be posted on Facebook or Instagram, or email it to a friend, or upload it as a thumbnail to another website, or whatever usage you have for it. If I wanted to make a print, I would export it as a high resolution JPEG or TIFF and use that for printing. Lightroom gives you a lot of flexibility in how you approach your image file management. So I hope you found this useful, and I know this was a pretty long-winded video. If you have any questions, drop them in the comments below. If you like this kind of content, be sure to like the video and subscribe to the channel. And as always, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.